These questions concern compound interest. So the formula that we're going to use is this one. When you're using this formula, A is the amount in the account at the end, P is the principal, the amount invested, I is the interest rate per period as a decimal, and N is the number of times that interest has been added. It's a good idea when you're using this formula to work out I before you start the interest rate, because it can be a little bit tricky. We want it as a decimal, so 9% is 0.09, but this interest is added quarterly. They're not going to add 9% to your account every quarter. That's an annual rate. 9% per annum is the annual rate. Each quarter they will add 1/4 of that interest to the investment. So what we need to do before we start is to get the interest rate 0.09 and divide it by 4. Give us a quarterly interest rate of 0.0225. Put the information in the question and we can work out the amount at the end. 5,000 is invested. The amount interest rate per period, 0.0225 as a decimal. And N is the number of times interest is added. Now this is being added quarterly for 8 years. 4 8s are 32 times interest will be added. Now if I was trying to do this on a calculator, I'm going to need at least a scientific calculator to do this, because I want it to have an x to the power y button. I want to be able to raise a number to a power. And in fact, if I was doing this calculation here, I can see that it is just this number that has to be raised to the power of 32, not the 5,000, just this bit. So I would probably start my calculation here. I would do that in my head, that's easy enough. 1 plus 0.0225 is 1.0225. Actually, it's probably easier to add 1 actually because it's on my calculator. Okay, I've done that. I want to raise it to the power 32. That's the only bit that I want to raise to the power 32. So I'll do that now. Raise to the power 32 equals. And then we've got to times our answer by 5,000. Times 5,000 equals, and it's got a huge number of decimal points, but that's not important. We're talking about a dollars and cents question, so answer to 2 decimal places, 10,190.52. Let's have a look at a second example. Compound interest question, compound interest formula. Work out I before you start, the interest rate. It's 4.8% per annum, but it's compounded monthly. So 4.8% as a decimal is 0.048. If you want to, just go 4.8 divided by 100 to get you interest rate as a decimal. But we need it per month. That's how much they would add every year if they were adding annual interest, but seeing they're adding it every month, they will give us 1/12 of that. So we'll need to divide it by 12 to get the monthly interest rate. So 0.048 divide 12 gives us a monthly amount of 0.004. Put all the information into the equation and we'll have 650, 1 plus 0.004 raised to the power, now it's been done for 5 years, monthly interest. So there's 12 months in a year, it will be added 12 times every year. Over 5 years it will be added 12 fives, 60 times. Okay, now it's 1.004 that we need to raise to the power 60. So I will do that first. I've got 1.004 raised to the power 60, and I'll times that answer by 650. Round my answer off for dollars and cents. I've got $825.92. But be careful. This question didn't ask me for the amount in the account at the end. It asked me for the total amount of interest added. The compound interest formula, unlike the simple interest formula, gives you the total in the account. That's what we've got here. The simple interest formula just gave you the amount of interest added. This question asked us for the amount of interest added. Now, if that's the total in the account at the end, we have to take off what we started with, that 650, to give us the amount of interest added. That's on the screen. $175.92. Okay, there's some questions over the page. Let's move over there and see what we've got. Here we've got two bank accounts. They're both earning compound interest. This one's compounding annually, where this one is compounding every month. We can use the compound interest formula to work out the amount in the account in both cases at the end of 5 years. A equals P times 1 plus I to the power n, and A equals P 1 plus I to the power n. Now, the interesting thing about this, in both cases the same amount is being invested, 1,500. In both cases it's being invested for 5 years. And in both cases it's 8%. The difference is that this one is compounding annually, this one is compounding monthly. Let's see how much is in the account at the end of 5 years in both cases. So, the value of I in this case, well, it's 8% per year, 0.08, and as it's compounding annually, we don't have to adjust it. So if I want to work out the amount in the end, the investment was 1,500, 1 plus 0.08, and n is the number of times interest will be added in 5 years. It's being added only once every year. Interest will be added 5 times. In the other case, work out I is 0.08 is the annual interest rate as a decimal, but this time I'm going to have to divide by 12 because it's being added every month. Every month they'll give me 1/12 of the interest. Work that out before we start. Or 0.06666666. Now with this particular calculation, people, I would strongly recommend you use plenty of decimal points here. 6 or 7 decimal places would be a really good idea. You see, we have to raise a number here to a large power. And when you do that, you have to multiply it by itself that many times. A very small difference in this can end up making a big difference in your answer. So with this particular type of calculation, use plenty of decimal points. Now, over here we've got a similar sort of thing. We've got $1,500. It's invested at 8%, but per month that works out to be 0.0066667, I suppose, rounded up. Raised to the power 5 years of monthly interest. Every month for 5 years, 5/12 are 60 times interest will be added. Which account gets the most at the end, and why does it? What I'd like you to do now is maybe pause the recording and can you work these out and come up with a reason why the two are not the same. Okay, here's my answer. Okay, two different answers, two accounts, they look similar, but this one gives more interest than that one. I said account B gives more interest because it compounds every month. Each month interest is added and it's calculated not on the amount that was there at the start of the year, but an amount which includes interest which had already been added each month. Very last question that we're going to do is also a compound interest question, compounded twice annually it says, so we're going to use this formula. But in this case, the variable we're trying to find is not the subject of the equation. It says how much needs to be invested to end up with 2,500. So A is 2,500 and our job is to work out what the value of P is. How much do you have to put in to end up with 2,500 at the end? Now, just before we go any further, we better work out our value of I. I is equal to 8%. You can write that as 0.08, but it's compounded twice per year. So every half year, they're going to give us half the amount of interest. 0.08 divided by 2 equals 0.04. So we'll have 1 plus 0.04. And how many times will interest be added? It's being added twice per year for 3 years. Well, that will make 6 times all in all. So 2,500 equals P times 1.04 to the power 6. Now, only the 1.04 is raised to the power 6. So I think I would start by doing that first. 1.04 raised to the power 6. I get an answer of 1.265. If I want to get P by itself in this equation, this is P times 1.2365. I better let you see this. Okay, 2,500 equals P times 1.2635. So what I'll do is I'll divide both sides by 1.2635 to get P by itself in the equation. 2,500 divided by 1.2653 equals P, and that will mean P equals, and on our calculator, the amount invested is 1,975.82. There we have it.